Welcome to the CP213 midterm number 1 review session. My name is Mila, and I'm here today with Noah and Tobin, and we're gonna lead you through the content for your first midterm. So hopefully this will help you guys out for tomorrow. So I'd like you guys to just please take this moment to sign in. I'll give you a couple of minutes. So just sign in right now. Okay. Do you think that's enough time? Can I start it again now? Okay. 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 Did everyone sign in? Does anyone need a couple more seconds? Yeah? Okay. Yeah, go ahead. No worries. Okay. Okay. These slides, I think we're good to, are we good to go? Yeah? Okay. Let's move on. All right. So some quick little things before we start. We've got two big upcoming events happening. So the first one being GitHub 101. It's going to happen this Thursday at 7 p.m. It's online. Definitely come check it out. You never know what you might learn. And as well, we have our next review session that'll take place after reading week on Tuesday, October 17th. So come out to that one as well. All right. All right. So today's agenda. So we're going to be covering Intro to Java and Object-Oriented Programming. We're going to go through console input-output, flow of control, and finally, we're going to take a look at arrays. And then at the very end, I forgot to mention this before. So you guys obviously all know about the Kahoot, where you can win some really great prizes. So be sure to stay after we finish all of our slides, because we're gonna play some Kahoot. We got a couple of questions for you guys, and you can win some really cool prizes. So that'll be kind of the breakdown of how our review session today will go. Okay, let's get right into it. So just some quick things right before we start as well. Some useful links and other resources. So the Math and Stats Learning Support Center is a really great place to go to if you ever need some extra help, as well as you also have some online resources you can use in case you ever get stuck. So some coding sandboxes, a really good Python, Java, and HTML sandbox. Replit, we would use it a lot last year in our review sessions as well. It's a really great tool. And then another one is CodePen. So if you ever need somewhere else, if you ever need to look somewhere else for some help, you should check out these places. And then moving on. So as well, just a quick reminder of some mental health resources. We know university can be challenging and difficult at times, especially around midterm season or final exam season. So definitely make sure to check in with yourself and stay healthy, stay safe. Some other resources: the SafeHawk app, Student Wellness Center, and the Counseling Center. So here we go. All right. So let's start off with our very first slide, Intro to Java. I also just wanted to let you guys know, because I see some of you taking photos, these slides will be posted. We're actually recording it right now, so that'll be posted to YouTube after. But we probably will release the slides as well. So there's no need to take photos. You can have access to them later if you need it. So let's get right into it. Intro to Java. So what is Java? Java is a class-based object-oriented programming language. So it's compiled Java code can run on all platforms that support Java without the need for recompilation. So what does this exactly mean? So what this means is that Java is a language where when we compile our Java code, it'll turn into bytecode. So this Java bytecode is then read through what is called the Java Virtual Machine, or JVM for short. And so if the best way to think about this JVM, I'm sure you've probably also heard your professor say it in the lecture before, but it's basically, think of it as a universal kind of entry point for bytecode. And so this, the JVM is essential, and it's what makes the Java language portable and accessible on any computer platform and operating system, right? It's the interpreter. It'll change it so that it can work on any of those computer platforms and operating systems. And for this reason, that's why it's a very portable language, and it's very accessible, and it's why it's preferred by a lot of different developers. So, I know that was a bit of a handful. Are there any questions on the JVM? No? Okay. Let's move, go back. Okay, let's move on to the next thing. So, just another quick little history fact. So it was created by Sun Microsystems team led by James Gosling in 1991. Now it's owned by Oracle. And Java is, lastly, it is a high-level language. So, implementation of a Java application. So the first thing that we want to do is, obviously, we want to create our program. So this is going to happen when we write our code within the main method. So this main method, I will say probably it's the most important method you need in your program, because if you don't have it there, you will run into a compilation error. It's just a keyword. It needs to be there in order for your program to run. And I'm sure you guys probably already know this. Maybe you've already run into this error before in previous lab or so, but just putting it out there in case. So number two, we actually have the compiling of the program. So to compile the program, so one thing actually I do want to know before I say this is, when I did this course last year, I would run all my code through Eclipse. I don't know if any of you guys do that now, but another way to do it, and I believe it has been covered in your lecture, is through the command prompt. And we're just going to cover that because knowing how to use your command prompt is a really, it's a good tool. Like, you should know how to use your command prompt. So if you guys ever want to try it out, this is how you can do it. So what you're going to do is you're going to run the Java compiler with the name of the source file on the command prompt, like as follows. So if you look over to the example, so we see Java C example.java. So our file is the example.java. So what you're just going to, you have Java C, that's our compiler, and then when you run that, what's basically going to happen is that it's going to compile it into binary bytecode using that compiler. And then we're going to get something called example.class. So that was the name, but you can see the extension's different, .class. That means it's now been transformed into that binary code, the bytecode. So now, because we've done that, it'll run on the JVM, which I was talking about before. That's how it's interpreting it, and then it'll produce our output. So in this case, our output is hello world. And there we go. And that's what's actually happening in the background, how your program is actually running and compiling. So are there any questions regarding this? Going once, going twice. Okay, perfect. Let's move on to the next slide. Okay, so here is a quick, cute little chart on the Java data types. So as you can see, there are obviously some differences from Python, which you guys were all doing last year in your 104 and 164 classes. So some things to point out, char, byte, short, long, double. I believe I didn't miss one. So some of you may be seeing those for the very first time, some of you may not, but it's very important to note that these are all supported in Java. That doesn't mean obviously that's the case for Python. Every language obviously has its own different syntax, but it's important to know characteristics about these and how you can use them in your programs. How are they working? So like I said, these slides will be posted. If you ever need to reference this, you can. You can go back and, I won't read through all of the size ranges or anything. But another thing I also wanted to mention, so operations. So addition, subtraction, division, multiplication, those are all operations that are also supported in Java. So just for your own reference. And then finally, if you guys, is there a certain, actually let me ask you all a question. So in Python, you guys had a variable, or not a variable, a data type called str, right, for string. Does anyone know why you can't see it up here? Yeah. Exactly, right. It's not primitive. It's not, in Java, we don't actually have a string data type. We use a string class. And I think that you guys haven't covered this like in depth and fully in like your lectures and stuff, and it's not gonna be covered on your midterm tomorrow, but just for your own reference, that is why it's not there. You guys will learn about it more later, the string class. So that's why it's not there. But yeah, let's move on to the next slide. Okay, so what is object-oriented programming, or short form OOP? You'll probably hear us all saying that a lot throughout this presentation. So, modular programming. Code is organized into separate modules or functions, each responsible for a specific task or functionality. Let me start off by saying first that in 104, CP104, you guys are doing modular programming, versus in 164, data structures, you guys did object-oriented programming, right? And so there's some key different things to note about this. So in 104, if you guys remember, you were using modules and you had different modules for different tasks or functionalities. But in data structures, you weren't using that exact approach. You had classes, right? You had a stack class, you had a queue class, binary search tree class. And then you had different methods inside of those classes that were used. Those were like the attributes, and those define the behavior of the class, of the object, actually, what it is. So even like I said here, so in what's 104, so these modules can be grouped together logically, and the program flow typically involves calling these modules sequentially. Versus we have OOP organizes code around objects, which are instances of classes. Classes define both data attributes and behavior methods. So let's give an example. So when we had our stack data structure, right? In our stack data structure, we had specific attributes that were like push and pop, right? So those methods, those were unique to the stack data structure. You wouldn't put those methods in a queue or anything like that, right? And so when you would call the stack, you created an object in your other file, wherever you were going to use it. And this made the stack, because you had the object, it made it very versatile. You could use this object to solve many different problems. And that's kind of the main reason why a lot of people favor OOP, because it's very versatile and it's very, it organizes code in a really nice way using kind of real world entities, if that makes sense. That's where the whole encapsulation principle comes into play. So, right, so the program structure revolves around defining and interacting with these objects. A stack, for example, it was versatile because you could use it for many different problems. This one particular object with particular attributes and behaviors, you could use it to solve different problems more efficiently. So, for example, stack you would use to solve the maze problem, or the balancing of parentheses problem, right? So that's why it's pretty favored. That was also another mouthful of talking. So, any questions here? No questions? You guys can ask, don't worry. Okay, let's move on to the next slide. It's just a quick little kind of summary slide. So you can see in the example, we have our class fruit, we've got our objects apple, banana, mango. So I kind of want you to relate this back to like data structures, where you guys had your food class, right? Food or movie, I don't know exactly which, I think it was, yeah, food probably. So you had your food class, and then when you created your food object, when you wanted to call, write that object in, like, let's say a testing file or wherever. You would create, let's say the parameters for one of your the food class was let's say origin and name, right? Whatever. So when we would make an object, we could make, for example, lasagna, for example, right? You'd put lasagna as the name, origin, Italian. And so that's kind of the idea, is you can make all these different objects we have different names, in the parameter, but they all fall under the same class because they all have the same methods going on in the background of the implementation of that actual class. So, is there anyone confused over that? No? Okay, so yeah, like you can see just the little summary up there. Modular programming is about writing procedures or methods that perform operations on the data, while object-oriented programming is about creating objects that contain both data and methods. And this is why we prefer it a lot more, and you guys are gonna keep seeing it around through the rest of your programming careers. So it's really important to understand and to get familiar with using it. So that is kind of the end of the intro to Java. I'm going to pass it over to Noah, and he's going to take you through the console input and output.
Hello, everybody. My name is Noah. Okay, let's get started with console I/O. Specifically, we'll start with console input. So here we have a screenshot of some code, and I'm going to walk through it with all of you line by line and make it make sense if it doesn't make sense already. So our first line, package CP213. So that's just saying which package we're working in. I called this package arbitrarily CP213 because I was making like sample code for a review session. So just CP213 was like a logical package name, but you can pretty much name it whatever you want. But a package is just a grouping of classes and interfaces into a file system which work together. So really the only like naming restrictions on a package would just be the naming restrictions of your operating system when it would name its sort of directory. But that's all a package really is. Think of it as just like a folder. But yeah, so package CP213, and then we import java.util.scanner because we want to use the scanner class. But if we want to use the scanner class in order to get console input from the user's keyboard, we have to import the class. Otherwise, the language won't know at all what we're talking about. So in that line, import java.util.scanner. That's when we import the class in order for us to use it. And then next, so public class review session. So because I wanted to make some sample code for this review session, I had to make like an arbitrary sample class for it. So I just called it review session.java, simple, random, arbitrary. But then and public static void main. So like we talked about earlier, how we do all of our coding in the main method. So this is the main method. It's within the class. So you can see the class, main method, package, hierarchy. That hierarchy is something that I'd recommend trying to remember for the midterm because it'll probably be on it if I had to guess. But yeah, so in the main method, first we make a new instance of the scanner class. We initialize a scanner object. So we say scanner equals new scanner system.in. So we're calling our scanner object just scanner. It's a very basic name, but it's like any variable. You can name it what you want. I could have said scanner X. I could have said scanner Noah, but I chose to say scanner. So scanner equals new scanner system.in. So the equals new, that's because we're instantiate, I can't even pronounce it, instantiating, however you say it, an instance of a class. So the equals new scanner, we're saying it's a new instance of the scanner class, and then we're giving system.in as a parameter. System.in is the standard input, which is just the user's keyboard. So we're basically saying that we're instantiating the scanner class, and we are saying that this scanner that we are initializing should be taking input from the standard input, which is the user's keyboard. So then we say system.out.print enter your name. So we print enter your name, and we don't do println. So we're not going to work on the next line when we start typing. If we start typing, we will be working on the same line because we didn't do println. So we didn't print a line break after the enter your name. So then we say string name equals scanner.nextLine. So we initialize a new variable called name. It's of a string type, and we say it's equal to scanner.nextLine. So scanner.nextLine, what is that? NextLine is a method from the scanner class that looks for the next string coming from the input choice that you put into your scanner object. So here we chose to make standard input system.in the input device of the scanner, but let's say we had made it be some other input device, then it would be taking the next string that it can get from that other input device. But because we do this, scanner.nextLine, it's going to store the next string that is inputted by the keyboard into this variable name, and it's going to store it in that variable name. So we do that, and we have that all being done on the same line as enter your name, and then the user hits enter, and next we're going to start working on the next line once the user hits enter, because that hitting enter, that is like a line break. So then we do system.out.print enter your age, again, not println, so we're going to be working on the same line now. But it's like this is the subsequent line, but I'm saying that after this line prints out, we do not make another line break. Then we say int age is equal to scanner.nextIn. Next in, it's the same idea as next line, but it finds the next int and stores it in an int variable instead of finding the next string and storing it in a string variable. So we say that this variable we've initialized called age, we say it's the next int that the scanner can pick up, and then we store it into that variable age, and we do this all on the same line. So we input our age on the same line as the line when we say enter your age. And then after that, we print on it, we break the line, and then after that, we do system.out.println so that the next output after this will be on a subsequent line. All right, unlike these prints, which would make it the next output not on a subsequent line. But we do system.out.println hello plus name, you are plus age years old. And these plus signs are just for string concatenation. But basically what this program did, it got the user's name, it got the user's age, and then just said hello, user's name, you are user's age years old. And then once we're done with this instance of the class, we do scanner.close, and that closes the object so that we don't have to use it anymore. Next slide, please. All right, and now we're going to go over, actually, were there any questions about input before I go over output? Yeah. The hierarchy thing? Yeah, sure. So basically, the hierarchy is like package, and then there are classes and interfaces within the package. You haven't done interfaces yet. They're near the end of the course. But think of interfaces as just classes for now. But basically, and like a package, it'll be different on different operating systems because different operating systems implement file systems differently. But a package is just your operating system's organization of the classes and interfaces together. So the way a package is implemented on a Linux system versus a Windows system is different because the file systems on Linux versus Windows are different, but the idea of a package is ultimately the same. It's just an organized directory containing classes and interfaces. Were there any other questions? Please don't hesitate to ask questions. Okay, I guess we can proceed with the output then. Okay, so console IO output. So system.out.println is what we use for console outputs. And system.out is an object that is part of the Java language. And the println method is invoked by the system.out object. And that lets us do outputs to the terminal. Remember, println, the ln stands for like the line break part. So when we do println, we're printing with a line break. If we just do print, then we're printing without the line break. We're just printing on that same line. So yeah, and the data to be output is given as an argument in the parentheses for system.out.println, and you can use plus signs to concatenate strings, which was shown on the previous example, also shown here. And every invocation of println ends a line of the output of the system.out.println, and ends a line, and then the output of this here is shown. So we'll go over this code again, but basically package CP213, the package once again, that's the class, that's the main, and then system.out.println, the answer is 42. That's what we put in the parameters, and then the output here, the answer is 42. So I think that's fairly straightforward. I'd say it's actually a bit simpler than the input, but does anybody have any questions regarding the output? No? Okay, in that case, we can move on to the next slide. So I'm going to give it now to Tobin to take over. Yeah.
All right, yo, how's everyone doing? There we go. I like the energy. All right, so now I'm going to be talking about flow control. So pretty much Java has branching mechanisms. So we have the if-else statement. It's kind of reviewed from like CP213, if and switch statements. Java also has 3 types of loop statements, which are while, do while, and for loops. And we'll cover this all in the next slide. So branching and looping in Java rely on Boolean expressions. A Boolean expression pretty much evaluates whether an expression is true or false. Those are the only 2 values that can come out of that. So if the Boolean expression is true, it's going to execute the yes statement. Otherwise, the no statement would be executed. So if you look at this example right here, we have an if statement that says if, bracket Boolean expression. And you can notice that we don't have any curly braces. And normally in if statements, we need a curly brace. But you may be wondering why in this case we don't need it. It's because inside this if statement, we only have 1 line underneath it. But if we had like more lines underneath the if statement itself, without any curly braces in between, then pretty much what happened is only the first line underneath the if statement would be treated as part of it, and it just skip on to the next line. Like it wouldn't even count it as part of the if statement itself. So a nested if statement, this is pretty much like new to you guys probably. So this is one if statement, basically sandwiched inside another if statement. So that allowing for multiple conditional checks in a program. So as we can look in this example right here, the class is called nested if example, and we have our main method right here. So in our first line, we're basically initializing x equal to 10, and then afterwards, we initialize y equal to 5, meaning we're setting y set to 5, and then we have an if statement right here. So we have if x is greater than y, so if that's true, which in this case it's true because 10 is greater than 5, then we have if x modulus 2 equals 0. So what modulus means is if we're doing 10 divided by 2, if the remainder is 0, that means that nested if is true. So since that's true, it's basically going to print the line x is greater than y and even. And that's what you can see in our output. That's the case. So you guys have any questions? Going once, going twice? All right, no one? Okay. We can move on to the next slide. All right. So now I'm going to go over switches and loops. So a switch statement in Java is a control flow statement that allows you to execute different code blocks based on the value of an expression. So in this example right here, we have choice being initialized to 2, so it's being set to 2. And then we have a switch statement. So it says switch choice, and then we have the curly brackets, and underneath that, we have different cases. So you can kind of think of cases like an if statement, and then you can think of default as like your else statement, and kind of in this case. So we have case 1, case 2, and case 3. And remember that these cases are based on the number of the variable that we're using in the switch statement. So in this case, it's choice. So if choice is 1, then it's going to print out you chose option 1. If choice is 2, it's going to print out you chose option 2. And then if choice is 3, it's going to print out you chose option 3. And if choice is not equal to either 1, 2, or 3, it's going to go to the default statement, which says invalid choice. So in this case, since choice is 2, the case 2 statement is performed, which means that what's being outputted is you chose option 2. And also another thing, under each case, you do need the line where it says break. And the reason why you need this under each case is that when you put that in there, it's basically terminating the loop and it's moving on. So it's terminating that function right there so they can move on to the next segment of code. But you don't need it in default. You only need it under case. So just make sure remember that for the midterm. Because a question like that might pop in there. So just giving you guys a heads up. All right. So a for loop in Java is a control flow statement that allows you to repeat to repeatedly execute a block of code a specified number of times. So for a loop, you have to pay attention for the number of times in this case. So in this example right here, we have a for loop that says for int I equals 0. So I is being set to 0. Then we break it off with a semicolon. I is less than 5. And then we break it off with another semicolon. And then we have a line that says I++. So that I++ means that I is being incremented by 1, meaning I is being added by 1 every time this for loop is being ran. And inside this for loop, we have a print statement that says iteration space plus I. I represents the iteration number. So when we're running this code, what we're going to have in the output is we're going to have iteration 0, 1, 2, 3, and 4 being printed out. But we don't have 5 being printed out because in our for loop right here, it says I less than 5. It doesn't say I less than equal to 5. All right, so does anyone have any questions about switch statements or for loop? Do you guys have any questions about that? Okay, oh, you got one? Okay, yeah, go for it. They put it like in your 213 slides? It's optional in that case. Like even if you have it even like this too, it'd be fine as well. So yeah, you're good for that. All right, so now I'm gonna go over the while loop. So a while loop in Java iterates over a block of code, meaning it runs over a block of code while a specified condition is true. So in for loop, we had number of times. The difference between for loop and while loop is number of times, and while loop is while a condition is true. So looking at this example right here, we have I being set to 0, and we have a while loop that says while I is less than 5. So while I is being less than 5, this block of code is still going to be iterated over and over again until it's equal then or greater than 5. So inside our while loop, we have a print statement, and it says system.out.println iteration and then the iteration number itself. So first iteration 0 is going to be printed, and then we're incrementing I by 1, so we're adding it by 1. So the second time this is being ran, iteration 1 is going to be printed, 2, 3, 4, and it won't print 5 because 5, as we see right here, it says I is less than 5, not equal to or greater than. So it's just going to end at iteration 4. So do you guys have any questions about while loops? No? Okay, we'll move on then. So now I'm going to pass the mic back to Noah, who's going to talk about arrays.
Okay. All right. Arrays time. So, sorry. Is the audio working or? Sorry about that. Does it work? There we go. Sorry about that before. Okay, so arrays introduction, and you might remember arrays from Python. Python arrays are very unlike arrays in most other programming languages. So what you know about arrays from Python will, in many instances, be pretty different in Java or for other languages like, say, C++. But yeah, if anything, a Java array is more akin to the arrays of most programming languages, so it'll be pretty helpful to learn about arrays from a Java point of view, in my opinion. You know, whether you're doing Java programming or non-Java programming. But so an array is a data structure used to process a collection of data that is all of the same type. So here we have a visualization of what an array is. So we have the following integer values organized sequentially: 40, 55, 63, 17, 22, 68, 89, 97, and 89. And these sequentially organized numbers, correspond to indices within this array. Sorry. And an array's base index is it starts at 0, and its like top index is always its length minus 1. So I think we're all capable of counting if we're in university. So you can see that this is like 9 things long, right? 9 elements long. So the top index is index 8. and the bottom index is 0. Here it actually says that underneath array length 9, first index 0, last index 8. So I think that makes sense. But anyway, so an array that behaves like this collection of variables, all of type double, can be created using either one statement like this, double square bracket score equals new double 5, or using two statements, double score, and then score equals new double 5. So are there any questions or no? Okay, bet. Next slide, please. So yeah, the individual variables that together make up the array are called indexed variables. And in Java, indices must be numbered starting with 0 and nothing else. So for example, for that double that we called score before, that double array, we have score at 0, score at 1, score at 2, score at 3, score at 4. Those are the 5 valid positions within the array. And a Java array is an object. Not all languages have arrays as objects, but in Java, arrays are objects. And an array has its length fixed when initialized. So that's untrue with Python, for example. So that was something that I brought up earlier of how Java arrays are, if anything, more akin to arrays in other languages than most arrays. Sorry. Yeah, in that regard, they're more akin to most of the languages, because most languages have their arrays with a fixed length, but yeah. And an array has its length fixed with, yeah, I just said that, sorry. Like Python, Java arrays can be multidimensional. So if you remember 2D arrays and multidimensional arrays from CP104, you can implement those with a Java array too. So are there any questions after that? There don't look to be. Okay, next slide. And so, okay, here's just a little code example with an array. So here we have a long form declaration. We say double A equals new double of length n, and we're just making a double array of length n, and then we're making a for loop. We're starting a counter, it's less than n, and we're saying that starting at 0, counting up until before n, that put the array at that index to set that value to be 0.0. So that's filling up the array, making every value be 0.0. The short form of this would just be double A equals new double of n, and then if you wanted to do the for loop, you'd still have to do that after, but that's the short form to initialize it. And if you actually want to initialize an array already full of the values, you could do it like that. You don't have to specify the length, right? Because it's not stupid. It can count just like how you can count, and it knows the length, right? So that's pretty cool. Any questions about that example? Quiet? Okay. Louder or quieter? Quiet down the room? Oh. Can people in the room be quieter, please? Straight up? Thank you. Great. Next slide, please. Okay, so now arrays, they have a fixed length, right? So remember how great they were in Python when the length was not fixed? Well, in Java, they sound pretty lousy with a fixed length. So what's the solution to that? Array lists. So array lists. An array list is a Java data structure and object which acts like an array with a dynamic length. A dynamic just means it can be changed. So array list of string represents an array list of string objects. And array list type list equals new array list type. That's how you would initialize an array list of a type. And the methods for the array list object are demonstrated on the next slide. But before we go to that slide, are there any questions about array lists? No? Okay, I'm once again going to remind the room to please keep it down. Thank you very much. Next slide, please. All right, so list.addElement. So this is how we can add an element to the array list if we want to. Type element equals list.getAtIndex. You can access the array list by its indices by using the get method. So let's say we have an array list of integers. If I want to know which integer is at the 7th index, I do int x equals list.get7. Boom, got that integer. Int size equals list.size. Pretty self-explanatory. And the remove method, there's two ways. If you want to remove by index, you do list.remove. You put the index as a parameter and you remove it. Or if you want to remove a specific element, you do list.remove. You put the element as a parameter. That's removed by the element. So are there any questions with that? There don't look to be. Okay. Next slide then. Next slide. Okay, Kahoot time.
All right, yo, at this time, so we'll pretty much have a Kahoot running up. We'll put it up pretty soon, so you guys can just log in, just like using the code that we're going to put up on the screen. We will be giving our prizes to the winners, so do keep in mind of that as we're playing this. But yeah, we'll just set it up right now. All right, guys, so we got the code up on the screen, so you guys can look at it right here. It's 500-7587. So you guys can go on kahoot.it, and you guys can type that down right now. Oh, wow, a lot of you guys joined quick.